Jeep Cherokee models are designed and sold with rugged off-road use in mind. Vehicle components, especially in the drivetrain, are designed to be tougher than those on passenger cars. But even tough components like these sometimes need service. Welcome to VideoTec. This month we'll look at the AccuStar 8 1/4 inch rear axle, new to selected Cherokee models. We'll review the basics of axle operation on rear-wheel drive vehicles, and we'll look at some of the causes of axle failure. Routine maintenance and typical service procedures will also be covered, with special attention being paid to the areas where this axle differs from those used on other Jeep vehicles. While this is the first time the 8 1/4 inch axle has been used on a Jeep product, it has proven its durability on Dodge B150 and 250 vans and wagons, and also on most Dodge Dakota and D150 pickup trucks. The AccuStar axle gets its name from the diameter of its ring gear and replaces the Dana Model 35 axle on Cherokees with the following features: a 3.55 axle ratio, 4-liter engine, and automatic transmission. Since the 8 1/4 inch rear axle was not designed to accommodate the Jeep 4-wheel anti-lock braking system, the Dana Model 35 axle continues to be used on Cherokees equipped with ABS. The new axle is available with either a standard or a SureGrip differential. The SureGrip name is new to Jeep products, but the differential is similar in function to the track lock system found on Dana rear axles. The 8 1/4 inch rear axle is easily identified by its housing cover, which is smoother and more oval in shape than the cover used on the Model 35 axle. It also features a rolled edge on the cover's flange. One of the nice features of this axle is that it is designed to allow the differential case to be removed without the use of a housing spreader. This simplifies axle service and lessens the chance of accidental damage to the differential housing. There are no exterior markings to help distinguish an axle equipped with a standard differential from one containing a SureGrip differential. But there are ways of identifying the differential without removing the housing cover. With the first method, you must remove the fill plug and visually inspect the axle components to see which differential the vehicle has been fitted with. Note the differences between the two differential cases. SureGrip differentials include a set of coil springs inside the differential case. The other method of determining if a vehicle is equipped with a SureGrip differential is to raise the vehicle by its frame. If, when in neutral, both rear wheels can be rotated in the same direction, then the vehicle is equipped with a SureGrip differential. In this case, the wheels rotate in opposite directions, and that means that a standard differential case has been installed in this axle. An axle on a rear-wheel drive vehicle performs several functions. Let's take a few minutes to review them. One of the basic functions of a rear axle is to support the weight of the vehicle. All rear axles used on Jeep vehicles are what is known as semi-floating axles. This means that the axle housing and drive axle combine to support the weight of the vehicle. Trucks designed for extremely heavy loads may use a full-floating rear axle, which uses only the axle housing to support the weight of the vehicle. All Jeep vehicles are designed to be driven by their rear wheels when four-wheel drive has not been engaged. The rear axle must be able to transfer the rotational force of the drive shaft 90 degrees and power the rear wheels. This is accomplished through the use of hypoid pinion and ring gears. The pinion gear serves as an extension of the drive shaft and is mounted in the front of the differential housing. It transfers power to the ring gear, which is bolted to the differential case. Please note that these bolts have left-hand threads. This is a unique feature of the 8 1/4 inch rear axle that you must be aware of. In order to make this 90-degree transfer of power as quiet and as efficient as possible, hypoid gears are used for both the ring and pinion. With simple beveled gears, the gear teeth are effectively meshed for just a small portion of the time. Hypoid gears are cut at an angle and provide constant contact with the gear surface. By the time one of the teeth on the pinion gear is leaving the face of the ring gear, the tooth following it is already firmly engaged. This allows a smooth and quiet transfer of power. This ring and pinion system works well as long as your vehicle is going in a straight line. However, As a vehicle turns, its wheels rotate at different rates, with the outside wheels traveling a greater distance. The sharper the turn, the greater the effect. This can cause a great deal of stress on the drivetrain and may produce serious handling problems. To help solve this problem, a differential is added to the axle. A differential adds pinion and side gears inside the differential case to compensate for the differences in left and right axle speeds. When driving in a straight line, the pinion gears remain still since both axles turn at the same speed. When the vehicle is turning, the pinion gears spin, allowing one axle to rotate faster than the other. Standard differentials divide torque evenly between the two axles, and this is fine in most situations. Unfortunately, in poor traction conditions such as sand, gravel, or ice, dividing torque evenly can lead to excessive wheel spin should only one wheel have traction. Sure grip differentials include an internal clutch mechanism that directs torque to the wheel with the best grip at any given time. This minimizes wheel spin and allows the vehicle to make the best use of whatever traction is available. This is particularly helpful in poor weather or off-road situations. As with any driveline component, careful lubrication is the key to long life and proper operation of the axle. The lubricant used in the rear axle protects not only the gears, but also the bearings supporting the pinion shaft, the differential case, and the axle shaft. Multi-purpose hypoid gear lubricant with an SAE rating of 75 W90 should be used for rear axles with either a standard or sure grip differential. The lubricant must meet API GL5 quality specifications. In addition, 4 ounces of Mopar gear lubricant additive should be included when filling sure grip differentials. This friction modifier is required for proper operation of sure grip differentials. Gear lubricant should be checked with the vehicle level and supported by its suspension. The proper level is approximately 1/2 inch below the fill hole. Be careful not to overfill the unit, as the lubricant may foam or overheat, and this could eventually lead to a damaged axle. Contaminated lubricants can also hurt axle performance. Water or metal particles suspended in the lubricant can lead to damage, especially to bearings. If the rear axle has been submerged in water, the lubricant must be replaced immediately. The axle lubricant level should be inspected at regular service intervals, and lubricant should be replaced every 30,000 miles. To drain the existing lubricant, drive the vehicle until it has reached its operating temperature. Then raise the vehicle, taking care to keep it level and supported by its suspension. This will allow an accurate reading when the axle is refilled. Clean all foreign material from the housing cover area. This will prevent contamination of the unit during assembly. Remove the differential housing cover and allow the original lubricant to drain completely from the housing and axle shaft tubes. Remove the remaining lubricant and foreign matter from the differential and housing of standard differentials with flushing oil or light engine oil. Do not use water, steam, kerosene, or gasoline for flushing. Sure grip differentials should not be flushed. Instead, they should be cleaned only by wiping with a clean, lint-free cloth. Confirm that the axle vent hose is in place and not clogged. This vent is necessary to prevent buildup of pressure in the axle that could damage axle or pinion seals. Next, scrape the remaining sealant from the housing and cover mating surfaces, taking care not to contaminate the differential. To provide a good seal, use mineral spirits to thoroughly clean the mating surfaces. Apply a 1/8 inch bead of Mopar silicone rubber sealant to the mating surface of the housing cover. Be sure to keep your bead inside of the bolt pattern. Let the sealant cure for a few minutes. Install the cover within 5 minutes of applying the sealant. Otherwise, you'll have to remove the hardened sealant and apply a fresh bead. Tighten the cover bolts to 35 foot-pounds of torque. Tighten the bolts in a pattern that will encourage proper seating of the bead and avoid warping the differential cover. Refill the differential housing with 4.4 pints of Mopar gear lubricant. Remember to include the 4 ounces of Mopar gear lubricant additive when filling axles with the Sure Grip differential. Replace the fill plug after confirming proper lubricant level. Test the vehicle for proper operation. On models with the Sure Grip differential, complete 10 to 12 slow figure eights to allow the lubricant and additive to work their way through the cone clutches in the differential case. While proper lubrication is vital to axle performance, vehicle overloading, excessive engine torque, and wheel spinning may also lead to axle damage. Axle overheating, chipped gears, and damaged bearings can all result from these types of abuses. Use Technical Service Bulletin 35190 as your guide to the 8 1/4 inch rear axle. The service procedures for the AccuStar 8 1/4 inch rear axle are similar to those of the Dana Model 35 axle, with a few exceptions. One of these exceptions involves the Sure Grip differential. Unlike the track lock system, the Sure Grip differential case is not a serviceable part. If it's defective, the differential case must be removed and replaced with a new unit. Testing the Sure Grip differential is fairly simple. With the ignition off and the gear selector in park, raise the vehicle on a hoist, taking care to properly support it by the frame. Attempt to manually rotate each rear wheel. If this is impossible or extremely difficult, the differential is functioning properly. If you're able to rotate either of the wheels, the differential is defective and should be replaced. To remove the differential case from either a standard or Sure Grip equipped axle, place the transmission in neutral and carefully raise the vehicle by its frame. Remove the rear wheels and brake drums. Mark the position of the U-joint, pinion yoke, and pinion shaft for reference. This is so that when the parts are reconnected, they can be returned to their original factory balanced positions. Disconnect the drive shaft from the pinion yoke and secure it out of the way with a rope or a wire. Do not allow it to hang, as this could cause damage to the drive shaft. Clean off all foreign material from the areas surrounding the housing cover. Then loosen and remove the cover bolts, allowing the lubricant to drain from the housing and axle shaft tubes. Rotate the differential case so that the lock screw securing the pinion mate gear shaft is accessible. Remove the lock screw and the shaft from the differential case. Press the axle shaft in toward the center of the vehicle. Avoid turning the axle shaft as you push. This could cause the pinion gears to work their way out of the differential case. Remove the C-clip locks from the ends of each axle shaft. Once this has been done, return the pinion mate gear shaft and locking screw to their original positions. The axle shafts are now ready for removal. Carefully remove the axle shafts from the housing. Do not rotate the axle shaft, as this can cause misalignment of the side gears. While this is easily fixed on standard differentials, realignment can be difficult on Sure Grip models. Keep the shafts level on their way out to avoid putting unnecessary stress on the axle shaft bearing, which will remain in the axle shaft tube. Before attempting to remove the differential case, mark the housing and bearing caps. The bearing caps are precisely machined with the housing and are not interchangeable from side to side. You'll also want to keep the differential bearings, cups, and threaded adjusters together, as they too are a matched set. Remove the threaded adjuster lock from each bearing cap. Loosen the cap bolts, but do not remove them at this time. These threaded adjusters are not found on any other Jeep axles. Differential case side plate is controlled on Dana units by a replaceable set of differential bearing shims. A special tool is required to service the threaded adjusters in the rear axle. Carefully insert this wrench through each axle shaft tube and into the threaded adjusters. Then loosen the adjusters. Once the adjusters have been backed off, the bearing caps can be removed and the differential case eased out of the housing. Be careful, as the case may want to fall after the bearing caps have been pulled. Keep bearings and cups, bearing caps and adjusters together as they are matched set. Axle shaft seals located at the outboard end of the axle shaft tubes are easily serviced once the axle shafts have been removed. Should the seals be leaking or showing signs of damage or wear, they will have to be replaced. This seal had been leaking. Remove it from the axle tube with a pry bar or a screwdriver. Then visually inspect the bearing for damage. Inspect each axle shaft for unusual wear at its contact point with the axle shaft bearing. This area should appear to have a dull gray finish and show no signs of being pitted or scored. If the contact surfaces of the axle or the bearings are damaged, they will have to be replaced. Follow the procedures described in Technical Service Bulletin 35190. In this case, the axle and bearings are in good shape. Wipe the area clean and apply a light coat of grease or oil to the new axle shaft seal. Using the seal installation tool, press the replacement seal into the axle tube. The new seal is properly seated when the installation tool contacts the face of the axle tube. Installing the differential case requires that special care be taken to maintain the tolerances prescribed by Technical Service Bulletin 35190. Improper adjustment during case installation could lead to failure of the axle components. Apply a coating of gear lubricant to the differential bearings, cups, and threaded adjusters. A dab of grease will help keep the adjusters in position during assembly. Position the adjusters on their threads so that there's plenty of room for the bearing cups. Then carefully position the differential case in the housing. Return the bearing caps to their original locations as marked during disassembly. Carefully align the threads on the caps with those on the adjusters. Install the bolts securing the bearing caps, tightening the upper bolts to 10 foot-pounds of torque. Use your fingers to tighten the lower bolts until the bolts' heads are lightly seated. Now we are ready to adjust the ring gear backlash. This is the amount of free play between the ring and pinion gears. A small amount, 5 to 8 thousandths of an inch, is desirable for a smooth transfer of power. Insufficient backlash can lead to overheating of the axle, while too much backlash will result in excessive axle noise and wear. Use the special wrench to move each of the threaded adjusters inward to eliminate differential bearing side play. Avoid over-tightening the adjusters. The differential bearing cups will not always immediately follow the adjusters when they're moved. To ensure accurate bearing cup response to each adjustment, the bearings must be seated by rapidly rotating the pinion gear back and forth. This should be done 5 to 10 times each time the adjusters are used. Insert a pry bar or a large screwdriver between the axle housing and the case flange to check for differential side play. Carefully continue to adjust the bearings just to the point where all side play is eliminated. Leave a small amount of backlash between the ring and the pinion gear. Install a dial indicator positioning the plunger against the convex drive side of a ring gear tooth. Check the backlash at 4 evenly spaced positions around the perimeter of the ring gear and record the measurements. The range of backlash variation between these points should not be more than 3 thousandths of an inch. Variations of more than 3 thousandths of an inch indicate a damaged case or gears that will have to be replaced. Find the position of the lowest recorded backlash and mark that gear tooth so that all future measurements will be taken with the same gear teeth meshed. Continue the adjustment procedure by loosening the right side adjuster and tightening the left side adjuster until a backlash of 3 to 4 thousandths of an inch can be obtained with both adjusters tightened to 10 foot-pounds of torque. Don't forget to set the bearing cups by rapidly rotating the pinion shaft each time the threaded adjusters are used. Be sure to remove the dial indicator when doing this. Once the proper backlash has been achieved, tighten the bolts securing the differential bearing caps to 100 foot-pounds of torque. Tighten the right side threaded adjuster to 70 foot-pounds of torque. Rotate the pinion gear to seat the bearing caps and then remeasure the torque. Continue this until a consistent reading of 70 foot-pounds is achieved. Next, reposition the dial indicator and measure the ring gear backlash. The acceptable range is from 5 to 8 thousandths of an inch. Continue increasing the torque at the right side adjuster and seating the bearing cups until the correct backlash is obtained. You need to move the adjuster very little to create a change of 2 or 3 thousandths of an inch. Check the torque at the left side threaded adjuster. It should now be approximately 70 foot-pounds. If it's considerably less, the complete adjustment procedure must be repeated. If the reading is acceptable, continue tightening the left adjuster and seating the bearing cups until a consistent torque reading of 70 foot-pounds can be measured. Once this has been completed, install the adjuster locks, making sure that the lock finger is engaged with the adjuster hole. Tighten to 90 inch-pounds of torque. Install the axle shafts. Use care to avoid damaging the axle shaft bearings and seals when inserting the shaft into the axle tube. Once the axles are in position, the pinion mate gear shaft will have to be removed so that the C-clip locks can be installed. Once the locks are in position, replace the pinion mate gear shaft and locking screw. Apply Mopar thread locker to the screw. This will prevent it from working loose. Now we're ready to check the side gear clearance on standard differentials. Improper side gear clearance will cause a knocking sound, especially at low speeds or when turning corners. Side gears are not a serviceable item on sure grip differentials. To measure side gear clearance, insert a matched pair of feeler gauge blades between the side gear and the differential case on opposite sides of the axle shaft. If side gear clearance is no more than 5 thousandths of an inch and the axle shaft is not contacting the pinion mate gear shaft with the feeler gauges in place, the side gear clearance is acceptable. Do this for both side gears. If the clearance is greater than 5 thousandths of an inch and the axle shaft does not contact the pinion mate gear shaft, record the clearance. Remove the thrust washer located between the gear and the differential case and measure its thickness with a micrometer. The sum of the recorded side gear clearance and the thickness of the thrust washer will determine the thickness of the replacement thrust washer. In this case, the side gear clearance is 7 thousandths of an inch and the thrust washer is 33 thousandths of an inch thick. A thrust washer 40 thousandths of an inch thick is needed. Mopar offers a kit of replacement thrust washers to accommodate this repair. Select the washer that is closest to but does not exceed 40 thousandths of an inch in thickness. That would be the washer marked with a triangle. According to the instructions included with the kit, it is 37 thousandths of an inch thick. When reassembled, side gear clearance will now be 3 thousandths of an inch, which is within the acceptable range. If the measured side gear clearance is greater than 12 thousandths of an inch, or the axle makes contact with the pinion gear mate shaft, a new matching set of side gears or even a replacement differential case may have to be fitted. See Technical Service Bulletin 35190 for more information. The contact pattern of the ring gear teeth can provide an indication of whether the rear axle has been assembled properly. It's also a good troubleshooting technique when diagnosing unusual axle noise. To find where the gear teeth are making contact, apply a very thin coat of hydrated ferric oxide to the drive and the coast sides of a section of the ring gear teeth. Rotate the gear 1 complete revolution in each direction while applying a load. This will give a distinct contact pattern on the gear teeth. Compare the results to those on the chart included in the reference manual, technical service bulletin, or service manual to confirm proper adjustment. Once an acceptable contact pattern has been achieved, reattach the drive shaft, taking care to align the reference marks left during disassembly. This will ensure proper drive shaft balance. Next, install the differential housing cover and refill the unit following the directions given earlier in the lubrication section. Note that the lubricant level when the vehicle is not supported by the suspension should reach the bottom of the fill hole. Install the brake drums and wheels. Tighten the lug nuts in the correct sequence to 85 foot-pounds of torque. Finally, road test the vehicle to confirm proper operation of the rear axle. Listen carefully for unusual sounds that could be a signal of problems. Replacement of a leaky pinion shaft seal is one of the services most often performed on a rear axle. Once the vehicle has been properly raised by its frame, mark the U-joint, pinion yoke, and pinion shaft for reference during reassembly. Disconnect the drive shaft from the pinion yoke and secure the shaft in an upright position to protect it from damage. Remove the rear wheels and brake drums in order to prevent drag that would distort bearing preload torque measurements. Rotate the pinion shaft several times, noting the torque as it's moved through several revolutions. Record the measured torque. Next, secure the yoke with a special yoke holding tool. This allows removal of the pinion shaft nut and Belleville washer. Use a puller to remove the yoke. Once the yoke has been removed, extract the pinion shaft seal with a puller. Clean the seal contact surface in the housing bore to allow the new seal to seat properly. Check the pinion shaft splines for burrs or wear. Inspect the yoke for cracks, worn splines, or a worn seal surface. Repair or replace the yoke as necessary. Use the seal installer to replace the pinion shaft seal. Replacement seals for the AccuStar 8 1/4 inch rear axle are pre-coated with a special sealant. While additional applications of sealant are not required, a light coating of gear lubricant on the pinion shaft can be helpful. The seal is properly installed when the seal flange contacts the face of the differential housing flange. Position the yoke on the end of the pinion shaft, noting the alignment marks made during removal. Seat the yoke on the pinion shaft and remove the tools. Install the Belleville washer with the convex side facing outward. Unlike the Model 35 axle, the pinion nut on this axle can be reused. Secure the pinion yoke and tighten the shaft nut to 210 foot-pounds of torque. Rotate the pinion shaft several times to ensure that the bearing rollers are seated and operating smoothly. Measure the preload torque of the pinion gear bearing. Carefully continue to tighten the pinion nut until the preload bearing torque is the same as your original recorded measurement. The bearing preload torque should be constant during a complete revolution of the pinion gear and never exceed the recorded reading by more than 10 inch-pounds. Never loosen the pinion gear nut to decrease the bearing preload torque. If the specified torque is exceeded, a replacement collapsible spacer will have to be installed on the pinion shaft. The pinion gear nut must be tightened to at least 210 foot-pounds of torque to be acceptable. Once the pinion bearing preload has been set, install the drive shaft following the reference mark left during disassembly. Tighten the yoke clamp screws to 14 foot-pounds of torque. Check the lubricant to the axle and road test the vehicle. That completes this month's VideoTec. Technical Service Bulletin 35190, issued as a supplement to the Jeep Service Manual, provides further information on the AccuStar 8 1/4 inch rear axle. In addition, Chrysler Corporation training centers offer a one-day course on servicing all Jeep front and rear axles. Featured topics include axle inspection, disassembly, reassembly, theory of operation, and more. The course is open to all technicians who are involved with axle repair. Use all of the available resources to take the mystery out of rear axle service and make your job as a technician just a little easier. We'll see you next time on VideoTec.